In this video, we're going to look at why you should consider studying advanced level physics. Yep, it's a difficult course. A lot of people say that it's the most difficult A-level course. And so if you're a very careful student, you might think, why would I choose to study a course where more people get lower grades than higher grades when I could study an easier course, get higher grades and get into one of those universities? Well, there's a presentation I'm about to give that I gave to my year 11s on just that point. So we're going to start by talking about a study that was done by the Institute of Physics. Now, this study was done back in 2010, so it's not hugely recent, but it was just after the last big financial collapse, done by the Institute of Physics to look at what happened to students who had graduated from physics at university 1 year after their degree. So these are physics graduates. This is way beyond A-level, and you may be surprised by what the results show. This is the most recent study that I've got from the Institute of Physics, and so the data isn't corrected for 15 years of inflation, but most of the data, I think, is pretty similar to what it is even now. So here are the career paths of graduate physicists 1 year after graduating. So these are physics students, BSc in physics or an MPhys in physics. And what's happening? Well, the majority of them go into education. There's about 500 here. You can add up the numbers yourself. The majority of them go into education, whatever that means. Might be teaching, but it might not be. I don't know. But look at this. This often surprises students. 91 out of the 500, so nearly a fifth of all physics graduates end up in finance. That is quite surprising. And an awful lot stay in scientific and technical industries, energy and environment, which I think would count as scientific and technical, so I don't know why it's been separated. Electronics, IT and software, which I would put as scientific and technical, so I don't know why it's been separated. So those three, 37, 40 and 78, you add them together, that is the majority. The majority of physics graduates stay in science. And that's ignoring things like government research, which are probably research to do with science. I don't know. So there we go. Let's move on to the next slide. The next slide is looking at employment prospects. So you can see three lines here. The blue line represents physics graduates 1 year after graduating, and the red line is the entire UK workforce aged 16 to 64. And you can see that there's not much difference between the two lines. But look at that green coloured line. That's all graduates 1 year after their course. And look how much higher it is. You can see it there. Look. Which way around is it? That way. You can... I can't get my orientation right. There we are. Look at it. Look how much higher that is. That's unemployment rate amongst graduates. Much higher. Like double, if not more, the unemployment rate amongst graduates. Physics graduates, about the same as the national average. All graduates, double the unemployment rate. So as far as employment prospects go, if you've got a physics degree, you're more likely to get employed than if you have a degree from another subject. Well, at least that's one way of interpreting these data. Okay, we can also look at what happens after your degree. Up to 1 year afterwards, where do you end up going? At this point, the IOP started separating between Russell Group universities and non-Russell Group universities, and that's very important. Many schools have a push towards Russell Group universities, saying that they are the gold standard, and indeed they are very, very good universities. And if you're on track for A's and A stars in your subjects, you should absolutely try to get into those Russell Group universities. But look at this, for physics graduates, the majority of, the larger share, let's say not majority, the larger share for students who go on to do master's degrees are from non-Russell Group universities, not from Russell Group universities. Okay, more Russell Group lot go on to do PhDs, but it could be people like me who did a master's degree at a non-Russell Group university, but then was offered a PhD place at a Russell Group university. This data doesn't show us what's going on there. But more masters at non-Russell groups, that might surprise you. That employed chunk is larger for the non-Russell Group universities. Unemployed, about the same. So that's interesting. Well, at least that's interesting to me. You might think about salaries then. Well, the IOP separated salaries into non-Russell Group and Russell Group graduates as well. Now, these are not corrected for inflation, so this is 15 years ago salaries, but you can see that if you want to earn up to $20,000 a year, go to a Russell Group university. That's what most of them earn. But look at this. Most of them that go on to non-Russell Group universities and get physics degrees 1 year after graduation, more of them are earning between $20,000 and $25,000 a year. That's very interesting. And in fact, if you look up to $25,000 a year in non-Russell Group universities, that's more likely to be you. Up to $30,000 a year, more likely if you're at a non-Russell Group university. Up to $35,000 a year, more likely if you're in a non-Russell Group university. And the pattern continues all the way up. So one interpretation of this would be that if you go to a Russell Group university, you're more likely to end up with a lower salary than if you go to a non-Russell Group. Now, that is really surprising, especially to students who are at schools that really push for those top universities. In physics, it really doesn't matter. If you go to a non-Russell Group university, your prospects are just the same, if not statistically maybe a little bit better than if you go to a Russell Group university. I'm not saying don't go to a Russell Group, I'm just saying don't dismiss the non-Russell Groups. We can also look at the sectors that employ Russell Group and non-Russell Group universities. And here you can see that we've separated the top classes of degrees first and the upper second class degrees. And over here, 2s and third class degrees. Non-Russell Group and Russell Group, staying in scientific and technical industries. Russell Group lower than non-Russell Group. You go to a Russell Group university, you're more likely to leave scientific and technical industries. That's interesting. If you get a top class of a degree from a Russell Group university, you're more likely to go into education and go into teaching than if you're in a non-Russell Group university with a first or a 2-1. You're likely to stay out of teaching. That's very interesting. The other one I thought was interesting is media and communications. Look at the size of this bit for media and communications. If you go to a Russell Group university and end up with a lower class of degree, then you're more likely to end up writing about science rather than actually doing science. But if you stay at a Russell Group university, you're more likely to end up doing science rather than just writing about it. So if you like science, should you be going to a Russell Group university? Now, there's a lot of data here. There's a lot of statistics, and statistics often, based on averages and things, it doesn't take into account individuals. So you've got to take this with a certain pinch of salt. But it's interesting. You can conclude that actually, this is everything I've just said. If you go to a Russell Group university, you're probably going to end up staying in the field of science, earning a larger salary. If you do physics in either of those types of universities, you're more likely to get a job as well. And if you want to go into finance, that's a sector that employs a lot of physicists as well. You want to do a master's or a PhD, physics degree, absolutely a useful thing to do because lots of physicists go on to do masters and PhDs. We saw that. So they are, I think, interesting conclusions. Now, I had a look on a job searching website for graduates, prospects.ac.uk. It's a job searching site for people who have just graduated and have a degree. And I searched for what jobs would be open to me with a physics degree. And this is what came up. We had things that you might expect, like astrophysicist, medical physicist, nuclear physicist, theoretical physicist, computational physicist. Yeah, okay, physicists. But you also had things like, over here, actuary. That's working in finance. Or we had over here, where is it? Data and analyst. You might think that a data analyst might require computer science. Apparently not. Metallurgist. You might think that a metallurgist might need chemistry. Apparently not. Geophysicist. Maybe you don't need the geology side of things. Patent attorney. Maybe you don't need to know anything about law. There might be other courses you have to do, but that's interesting. I did like the fact that you can see actuary right there. And in fact, the IOP on their website, and I looked up the jobs only on Wednesday last week, and I looked up from the IOP what the career paths were just last week, and found things like VFX and gaming. Not computer science, but for physicists. Robotics and AI. Not for computer science, for physicists. Finance and law. Not for economics, not for law, but for physicists. These sectors need physicists. Yes, robotics and AI needs computer science. Yes, VFX and gaming requires artists and architects and all that sort of thing, and computer scientists. And yes, finance and law needs economists, and it needs people with law degrees. But there's more than that. Medical physics with a physics degree, nothing to do with medicine. These are sectors that are open to physicists, not just physics. There's a lot of jobs out there that the IOP is talking about being available. So what courses at university need A-level physics then? Let's look at that. You've convinced me that I want to do a degree in physics, or maybe not, but I'm talking about A-level physics. So what courses need A-level physics? Well, you've got to be careful and check universities' individual requirements, because they are very, very different. So I looked up the University of Oxford, kind of the gold standard for physics courses, and they're offering all of these. Even biological physics, which sounds like an interesting area. I know that Professor 𝗟𝗶H is working on that area at the moment. And you obviously need a physics A-level to go to the gold standard university and do the absolute top tier courses. But let's say that I've chosen to do A-level physics and not chemistry. Let's say that I made that choice, and now I'm starting to think that actually I was actually more interested in chemistry. Have I ruined my prospects? Well, no, because these universities actually allowed you to study chemical engineering without a chemistry A-level, if you had physics. And I think that's interesting. These aren't bad universities, and yet you can study chemical engineering with an A-level in physics, and in those cases, without an A-level in chemistry. And I'm not saying don't do A-level chemistry if that's where your passions lie, but what I am saying is that there are options. The doors aren't shut to you if you choose to study physics instead of chemistry. That's interesting to bear in mind. Does that surprise you? Well, the fact that you can do chemical engineering without chemistry should surprise you. Physics keeps options open. That's what we're saying here. So what else have we got? Well, let's say I want to do medicine. And I often hear the statement that if I want to study medicine, I have to have a A-level in chemistry. Well, that's not true. Now, there are more options if you do an A-level in chemistry. There are more courses that offer medicine with an A-level in chemistry. That is true. But that doesn't mean if you choose physics over chemistry, you are shutting the door to medicine. These universities all offer medicine courses with a A-level in physics, and in the bottom 5 cases here, Kiel, Leicester, Manchester, Sheffield, Sunderland, A-level in physics and biology, but you could even do an A-level in physics and an A-level in psychology. You don't even need biology. They'll take you on to medicine if you've got that physics there as well. So there are options for medicine if you haven't chosen chemistry. That doesn't mean don't do chemistry, because you might have your heart set on medicine, and there are more options in medicine if you do have an A-level in chemistry. And you'll often hear people say it's easier to do medicine if you have a chemistry A-level. I don't think that's true, because we do a lot of unit conversions and we do lots of material science and gas laws and stuff in A-level physics, so those skills are going to be learnt in A-level physics anyway. So what about engineering? Do you need a physics A-level to get onto an engineering course? Well, no. I suppose if I'm being completely honest, there will be universities that will accept you onto an engineering course without an A-level in physics. There aren't many of them, and I did find some, but they were quite rare. And it's quite difficult to get onto them, I suspect, because you're going to be competing with other people with physics. I suppose that's the same for a chemistry for medicine, although I've known plenty of chemists without plenty of medics without chemistry. But if you want to do mechanical engineering, that's just physics. Aeronautical engineering is just physics. Automotive engineering is just physics. Electrical engineering is just physics. Nuclear engineering is just physics. Civil engineering is just physics, and so on and so on and so on. These courses are physics, with a different name and perhaps more application-based, but they are physics. So the physics will unlock all of the physics courses that are out there at the top-tier universities, and all of the engineering courses as well. It doesn't stop you from studying medicine, and so that's another good reason to consider physics. But also, if you want to go into finance, but you're more sort of scientifically minded, you don't really like the idea of doing economics and doing lots of essay-based questions, well, look, do physics, because that's what the financial sector wants, writing models to solve problems. And what will you do in a physics A-level? Well, in a physics A-level, you are going to, as it says here, learn about the fundamental building blocks of material reality. This is top-tier science. You know, the true nature of space and time. But more importantly, you'll be learning how to apply mathematics to new situations so you can solve any problems. And that's what makes an A-level physicist so marketable in things like finance. What will you get to do? You will have to handle lasers, handle radioactive sources. I regularly do experiments in my lab. We're up to 200,000 volts, where we're using things like the flame probe. This is what A-level physics is like. GCSE physics, rolling cars down ramps and timing stuff with stopwatches. A-level physics steps up a gear. We're not just learning stuff, we're doing stuff. It is a brilliant course. Now, my school, we offer AQA A-level, so do check out what the A-level options are in other schools, or the school that you're going to. But in my school, because we offer AQA A-level, there are 3 exams. Paper 1, which is mostly what's done in Year 12. Paper 2, which is mostly what's done in Year 13. Paper 3, which includes practical work. And then the option that we offer in my school is quantum physics and special relativity. Proper physics. This is what we're talking about, really getting into it. Now, let's say you're sold on this now. You're thinking, yeah, A-level physics sounds really good. I want to understand the nature of reality. Can I do it? Am I clever enough to do it? Well, that's why I started talking at the beginning about Russell group versus non-Russell group. These are the data from my school. Now, I think I'm allowed to share these because they're public examinations and there's no names attached to any of this. So I think it's okay for me to share them. If this video gets taken off, it's because I've been told off by my head teacher because I'm not allowed to share it. But I think I am. So what can we see from these data? Well, in physics, there's an obvious trend. If you got a grade 7, this is only over the last 2 years of results, a student who got a grade 7 in their GCSE, none of them in 2023 or 2024 went on to get B's, A's or A stars in A-level physics. That's just a fact. None of the grade 9 students from GCSE who went on to study physics got less than a D in A-level physics. And you can see, I've colour-coded it so you can see there is a pattern. Now, this is something to be aware of. You could get a grade 9 in physics at GCSE and finish with a D at A-level. That was one student. No, 2 students, I think. maybe more. Maybe it's a couple of students. I can't remember. Doesn't matter. And over here, we've got one student. That's definitely one student that got an E, who's got an 8 at GCSE. Imagine that. You get an 8 at GCSE, and on A-level results day, you open the envelope and it's an E. Something's gone very wrong. But that can happen. That doesn't mean all is lost, but it can happen. So I would say that if you're on a grade 7 at GCSE, be aware of the hill you've got to climb and, plan your future accordingly. If you're not likely to get B's, A's and A stars, that doesn't mean you can't go to university and study physics or engineering, but you might have to be more selective with the universities you apply to. Now, I've included here all of the A-level courses that are offered by my school, and you can see that some subjects do accept people with grade 6s and some actually even below. And there are plenty of subjects where you can do very poorly at GCSE and yet do very well at A-level. And so if you're sort of in that sort of category where you're doing quite badly in your GCSEs, things aren't quite working for you, and you're thinking, actually, I'm not that sold on physics, well, there are other options. Look, all is not lost. You can still go on to do very successful A-levels if you choose the right courses. I'm just here to talk about physics. So let's say you're on track for a grade 8 and a grade 9 in physics. Yeah, do A-level physics. It's a good choice for you. If you're on track for a 7, well, it depends. Because if you're getting 7s and 6s in all of your subjects, then your prospects might be better with some courses, but then what? Because you might have A-levels in subjects which are maybe B's and A's, and then there aren't any courses for university because they need all A's and A stars for those particular subjects. It's possible. Whereas in physics, there are so many options for people who don't quite do as well in their A-levels. I'll come back to that later. So this is a question from Year 6. This is a Year 6 SATs question. So everyone sits and does Year 6 SATs, and they sit there and they do this. Oh, that's split screen. Let's not do that. Just screen. There we go. They sit there and they do SATs exams, and they get asked questions like this, where they're given a formula, 0.4 times x plus y plus 42, and this is a formula here, and then they're asked to plug numbers in and get an answer. Get a formula, plug numbers in, get an answer. Okay, fine. Fast forward a few years, 5 years, and what does GCSE physics look like? Well, we're getting a formula, we're plugging numbers in, we're getting an answer. Sometimes there's a few formulas, but it's still basically just getting a formula, plugging an answer in, plugging numbers in, and getting an answer. It hasn't really advanced much beyond that. But what about A-level? Well, in A-level, the next slide, this is just 22 weeks after the GCSEs. So just not 22 weeks of school, just 22 weeks after the GCSEs, this is what the whiteboard looks like. You can see we've got V equals epsilon minus IR for internal resistance. You wouldn't have done that yet if you're in year 11. We're writing some equations, and then bang, we're writing a differential equation. We're using the product rule. We're using the chain rule to solve this. And all the way through this, almost 2 whiteboards, 1.5 whiteboards of work to prove that R equals R. And that is a typical board for A-level physics, just 22 weeks after you've done your GCSE. So if you're not competent with algebra, you're getting a grade 7 perhaps in physics, but in mathematics you're struggling with algebra, physics might not be for you, because we're going to assume you can do algebra. Obviously we're going to teach you up to this point the other way, up to that stage. We're not just going to jump in straight away with differential equations, but 22 weeks, and that's not all teaching time. 22 weeks is not a long time to get caught up with this sort of thing. And so if you are one of these that's down here somewhere on a 7, but mathematically you're strong, good. But if you're down here somewhere and mathematically you're weak, you're probably going to end up right down there, and that's not where you want to be. So let's bear that in mind. Right, so there are 2 schools of thought about how to encourage people with their A-levels. One is discourage weak students from studying physics. Now, if we do that, strong students will listen to that message that A-level physics is very difficult, and a lot of people actually end up underperforming, and they'll think, I don't want to do physics because I'm more likely to get a good grade if I do a different subject. And then we end up discouraging the wrong people. The other school of thought is to try to encourage everyone to study physics. Now, if we do that, we then have the situation where weak students are also encouraged to do A-level physics. And what do I mean by weak students? Well, I mean those perhaps on a grade 7 at GCSE level. Maybe they're okay at maths, but they're still on the fence. They're not sure whether they should do it or not. Should we be encouraging them to do A-level physics when they might end up with a grade C or a D in A-level physics? Is a C or a D worth getting in A-level physics? I mean, for plenty of subjects, the answer to that would be no. It's not worth having a C or a D as an A-level because you can't do the next step, university or a higher level apprenticeship, with those sorts of grades for that particular subject. But physics isn't like that. So on Wednesday, last Wednesday, so this is recent, I went and I looked up entry requirements to physics degrees, not engineering, physics degrees. And this is what I found. You can see there we've got things like the University of Sheffield offering physics degrees for students who have DD. 2 Ds at A-level, and that's it. Now, that is a physics degree with a foundation year, so it's a 4-year bachelor's degree. But by the end of it, you would have a degree in physics, an honours degree in physics. You'd be a physicist. And in A-levels, you got 2 Ds. Or you've got things like Swansea University, CDD, or University of Surrey, physics with astronomy, with a foundation year, CCC. It's a 4-year course, but you end up getting a degree at the end of it, a reputable degree. Remember, non-Russell Group universities have the same prospects for graduate physicists as Russell Group universities. No benefit to going to one of the top-tier universities with the A*A offers compared to one of these with the CDD offers. Okay, maybe I'm stretching the statistics a bit, but that's, it depends so much on the individual. All of the physics degrees are all accredited, if we want to use that word. They're all the same. I think you get a really good quality of education at the Russell Group universities, and in some ways I really wish I was clever enough to go to them, but in my A-levels I wasn't. In my A-levels I was not clever enough at all. In fact, let's have a look at my results. Here they are. This is what I got. This is, I went to the University of Salford, which is not a Russell Group university. It's currently in the top 50 for physics and much lower than that for other subjects. They are currently offering physics with foundation year. That's not what I did. I did physics with photonics. I did a master's degree. But their current offering is physics with a foundation year BSc honours with the entry requirement of a CC. I got an A in ICT, a C in physics, an E in mathematics, and a D in AS music. That's what I got. I got onto a master's in physics with photonics and did really well at it. And I'd like you to think, or I'd like to think that you think, that I actually know quite a lot of physics. I think I do anyway. So what happened in my A-levels? Well, I discovered alcohol, I discovered heavy metal music, and my results dropped really badly to those results. All was not lost. Even though I got an E in mathematics, I managed to get to the University of Salford, and I managed to finish with a really high class MPhys honours physics with photonics degree. I was 0.5% away from a first class. It's a constant source of frustration for me that I didn't quite get that first class, but it's okay. 2-1 still got me onto PhD courses, so all is not lost. That's the power of physics at A-level. That's the power of physics. Such a hard subject. And so few people are doing it that you become incredibly marketable with that A-level. Really worth bearing that in mind. Now, what's the workload like for A-level physics? Well, this is my school. In my school, we have 4 hours and 10 minutes of lessons per week split across 2 teachers. That's what we have on average. And after each lesson, I reckon there's about 75 minutes per week, 75 minutes of summary questions per week. That's what I reckon, per teacher per week. Then I set about an hour's worth of Isaac physics questions for my students per week as well. And finally, there's the lab work, which it bunches up at certain times, and then there's other times where it's a bit quieter. But if you average it across the year, it's about 40 minutes per week for both teachers. Now, when you add all that together, you get about 4 hours and 10 minutes of homework on top of the 4 hours and 10 minutes of lessons. That's what I reckon it is. As much time in lessons as outside of lessons. Now, all A-level subjects will tell you that that's what's needed. But in physics, you don't tend to be just cut loose and told, off you go figure out what you need to do. Because we've got things like Isaac physics that you can use to make sure you've got structure to the work you're doing. So you will always know what homework you need to do. It's very, very useful for those people who need that sort of organisation, who just being cut loose and told, off you go do independent work. That's difficult for them. How can you prepare for an A-level? Let's say I've convinced you. Let's say you're now thinking A-level physics is the course for me. How do I prepare for A-level physics? Well, in that case, there is summer work that you can be doing. I'll tell you about it now, but you'll forget it by the summer, but don't worry. I've got a series of videos. There are 6 videos, about 2 hours in total for the whole lot, about how to prepare for A-level physics. You should watch them. And at the end of each video is a QR code that leads to some Isaac physics questions. You should do them. And then there's an Isaac physics test, which will test your ability to do various skills that you are supposed to acquire before you start A-level physics. And I recommend you do that before you start. Now, in my school, I then, 2 weeks after the start of term, include those skills on the first test that Year 12s do. So that's why it's a good idea to do these skills. And these skills actually are GCSE level. At vectors, you do that in GCSE. Algebra, you do that in GCSE. Logarithms, apparently you don't do that in GCSE, but you jolly well should. Dimensional analysis, you don't do it in GCSE, but if you learn it before the start of A-level, then the A-level will be a whole lot easier. Graphing skills is GCSE, and errors and uncertainties, that comes up in GCSE physics as well. So a lot of this is just GCSE. There's only a couple of bits like logarithms and dimensional analysis, which is actually new. So I'm going to leave you with this. Physics, it's not about memorising equations or memorising facts and definitions and rolling cars down ramp and all that sort of thing that you do in GCSE level. That's not physics. Physics is about understanding the fundamental nature of physical reality. That's what it's about. This lovely statement here from 𝗟𝗶H, the power to decode the universe, pure cosmic adrenaline. I don't know if I like that phrase, but it's inspiring. But I do think that bottom statement there, I absolutely agree with. If you have the capacity to study A-level physics, my opinion is that you have the moral duty to do so. So just keep that in mind. And I offer tuition. Have a look at physicswithkeith.com for details. Like and subscribe.